Okay, in this video we're going to explain molecular compound formulas using Lewis dot diagrams. I'm going to be using the steps that are in this section of your notes. The steps go 1 through 7, and not every one of the steps is going to be necessary for every one of the molecules. So the first step is to determine the total number of valence electrons in the molecule, and the second is to select the atom with the most unpaired electrons. That's your central atom. Place the other atoms around the central atom and place one pair of electrons between the central atom and each outer atom. Add pairs of electrons around each outer atom to complete their octets or lone pairs. Place any remaining valence electrons on the central atom as lone pairs. If the central atom's octet is not complete, move a lone pair from an outer atom to a new position between the outer and central atom, creating double bonds. Create this until the central atom has a complete octet. If the molecule is an ion, then square brackets are placed around the entire structure and the ion charge is superscripted to the right of the brackets. So I'm not going to directly reference that again, but this is a progression. Methane is maybe the easiest of these molecules. Carbon has 4 valence electrons and hydrogen has 1, but there are 4 of them, so 4 plus 4 times 1 is 8 valence electrons. Carbon has 4 bonding electrons, so it has many more valence electrons, bonding electrons than hydrogen. So I start by drawing my central atom of carbon. Then I draw a bond between the central atom and each of the attached atoms. And in this case, I have completed my 8 valence electrons. 2, 4, 6, 8. So I've used all my valence electrons. I don't put any more out. Hydrogen can only accommodate 2 valence electrons because it's in the first period. So this is a complete Lewis structure, so we don't need to go beyond that. Hydrogen, we have 2 hydrogens, 2 times 1 plus 6 for the oxygen, still 8 valence electrons. Oxygen has 6 valence electrons, it has 2 bonding electrons, and hydrogen has 1, as stated before. So oxygen is my central atom, and I'm going to create a bond between the oxygen and the hydrogens. So I've used up both of my hydrogens, and I put a bond between oxygen and hydrogen. I would fill up hydrogen to its full octet, but hydrogen is full because it can only take 2 electrons. So now what I do is I use the remaining electrons. So I have 8, I've used 4. I put the other ones on the central atom to use them up. Now oxygen has 8. Hydrogen's energy levels or octet is full as well. And this is a complete molecule. This one, sulfur, is in the same group. It's group 16 as oxygen, so it has 2 bonding electrons. Fluorine has more valence electrons, but it only has 1 bonding electron. So sulfur has 6 plus 2 times 7, so that gives us 20 valence electrons for sulfur difluoride. Sulfur is my central atom, so I put a bond between sulfur and a fluorine. Sulfur and a fluorine. And then the instructions say that I should fill up the octet for the attached atoms. So I'm going to fill up fluorine's octet, and I'm going to fill up this fluorine's octet, and this is 2, 4, 6, 8, and another 8, so I've used 16. That gives me 4 more. So if I fill up sulfur, it's now 4 plus 8 plus 8 is 20. This is a complete Lewis diagram for sulfur difluoride. Carbon, again, has 4, hydrogen has 1, and oxygen has 6. So carbon is still my central atom. I make my bond to my hydrogen, I make my bond to my hydrogen, and a bond to oxygen. I fill up the octet. Hydrogens are full, but I will fill up my oxygen. At this point, though, oh, and I didn't count them, so I had 4 plus 2 times 1 plus 6, so I've got 12 electrons here. The 2, 4, 6, 8, 10, 12 electrons uses them all up. But the problem is that carbon doesn't have a full octet. So what I need to do is I need to take a pair of electrons and move them down here. And what I end up getting is a carbon that's still bonded to the hydrogens. It's still bonded to the oxygen, but the oxygen now has a double bond, and it's only got these two other lone pairs. So my carbon has 2, 4, 6, 8, and my oxygen has 2, 4, 6, 8. This is the complete Lewis diagram for this molecule. It's called methanol. You don't need to know that. Carbon dioxide, carbon has 4 plus 2 times 6 for oxygen, which is equal to 16 valence electrons. Carbon is still my central atom. I'm going to bond it to oxygen. I'm going to bond it to oxygen. I fill up the octet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 8 plus 8 is 16. I've used up all the electrons, but you can see carbon only has 4 valence electrons now, and it needs 8. So I'm going to take a pair and make a double bond, and I'm going to take this other pair and make a double bond here. So what I'm going to end up with is carbon with a double bond to an oxygen. The oxygen still has those 4 electrons. My double bond to oxygen and 4 to the electrons. And now my carbon has 4 and 4 is 8. Oxygen has 2, 4, 6, 8. 4, 6, 8. And carbon dioxide is complete. The last one that I'll show you is nitrate ion. Nitrate ion has 5 electrons for nitrogen plus 3 times 6 electrons for oxygens, but it also has 1 extra negative, so plus 1. If this was a positive number, we would lose an electron. So this is actually going to end up being 24 electrons for nitrate. Nitrogen is my central atom, bonded to an oxygen, bonded to an oxygen, bonded to an oxygen. Fill up my oxygens. And that's now 8, 8, 8 is 24, but my nitrogen doesn't have enough electrons. It only has 2, 4, 6. So as you imagine, I'm going to move this in to make a double bond, and I get a nitrogen that's bonded to my oxygen with a full octet, nitrogen bonded to an oxygen with a full octet, and then a double bond to an oxygen like this, and this whole thing has 1 extra electron that gives it a -1 charge. And so that's how you handle polyatomic ions, which are still have covalent bonds holding them.